So welcome back, everyone. We are about to start our next session. And I'm welcoming our moderator for the session, Mindaugas Mačernis from Vilnius University, Lithuania. The floor is yours.
Thank you. Hello, I'm Mindaugas Mačernis, and I will be moderator as presented for this session. And the first keynote speaker is Andreas Wierse. He studied in mathematics at Bonn University and got his PhD in engineering at Stuttgart University 22. After founding two spin-offs focusing on virtual reality for simulation, he joined SICOS BV and as managing director. Welcome. Floss Yo, he will present us discover how supercomputing can revolutionize research. Yeah.
Thank you very much. And I would also like to thank you for inviting me here. Actually, it's quite funny. When I was 16, which is quite a long time ago, my father gave me a nice book about great spaces spots in Europe. I later learned it was an advertisement from Coca-Cola, but and in there was Riga, and there was such a nice description of Riga with young people and nice weather and everything. So I decided at 16 I have to go there. So when you asked me whether I would like to come, you were, well, the doors were already open. I readily said yes, of course. And well, the weather's nice, young people are here, and I even had a Coca-Cola already. But no, thanks a lot. It's great to be here, and I'm happy to talk about what we are doing. Following this morning's presentations already, I was wondering a little bit where I should put the focus on. In order to be a little bit more precise, I would like to know a little bit more about you before I start. Who of you actually works in the context of, let's say, an HPC provider, has to do with a supercomputer and tries to get users for it? How many of you? Okay, that's significant. How many of you are actually users of HPC systems? Also, quite nice. How many of you are in industry? Okay, 1, 2, okay, don't be shy. So, because my focus at what we do at SICOS BW is actually industry. So I hope that you all get something out of it. I heard there are also some government people here, so probably a last call. Who's from government, funding agencies, etc.? You're really shy. Well, okay. So let's see about revolutionizing, which is a big word. We'll put this into context. I would like to begin in history. Well, not when I was 16, but I was 22 then. Because where I'm coming from, Stuttgart region, and we have a quite good long history about supercomputing, and it kind of started. Well, that's not Stuttgart, but it's our surrounding. Stuttgart and Baden-Württemberg is known for startups, for startup companies, for entrepreneurs. You know them all. They are called Bosch, they are called Daimler, they are called Kärcher, they are called Stihl. They used to be entrepreneur startups probably 100 years ago, but our region is really good at getting things started and then growing them. So that's where we come from, and the world is a village, so to speak. Competition in the past was more like the neighbor valley or village. In the meantime, we know competition is worldwide. So when I heard about cooperation in the previous panel, I thought, yeah, that's really an important thing. We learned that the neighbor company is actually not really competition, but they could be a good partner. And so we have a innovative and powerful region, which makes some things a little bit easier. you are aware of that as well. But it doesn't mean that it's easy, and it doesn't mean that it's more difficult for you. It's just different. But I think there are some lessons I would like to, that we learned, that I would like to share that probably can help you as well. And having a revolution in my title, we also have a revolutionary. It's a little bit, strange. Actually, he was our prime minister. So typically, revolutionaries are not the government, but the others. But he acted like a revolutionary. When he traveled with my doctoral thesis supervisor and the chancellor of the university, he traveled to the United States to look for new supercomputers in 1985. They already had a Cray 1, a smaller one, and they wanted to have, think about the follow-up system. And there must have been a really good presentation and probably a great dinner like we'll have tonight, with lots of wine, because around midnight, he decided my state needs such a Cray supercomputer. And next morning, he just signed a pre-contract without asking anybody else. Not his cabinet, not his parliament, nothing. Just signed a pre-contract for 60 million Deutschmarks, which today is probably, I don't know, 100 or 150 million euro. This was 40 years ago. He just did it like that. And that, well, it's unthinkable of today. I think, I don't know many states in the world, but that would be, it would be possible today. I'm sure that in the European Union it wouldn't be possible. But he did it, and he came through by it. He was lucky. By the time the system was delivered, the exchange rate to the dollar changed, and it was only 48 million. So he saved something like 20%. But what he also did at that time, he not only brought the system, but he already thought about these entrepreneurs and said, I want my business people, my SMEs, my industry to use the system as well. I know it's difficult, so we created 10 positions for consultants, SME, HPC consultants. And this happened in 1986. And his tool, that's the Cray 2, which actually, if you ever come to Stuttgart to the HLRS there, the system is still there. It makes up for a great bar. It's about 1 ton in weight. And I guess the metal value today is okay, but other than that, nothing's left from the 48 million. But the idea where we are going, the direction we are going. So he bought this Cray 2, he created the positions for SME consultants, and he failed. Well, how did he fail? Well, the system was a success, the researchers used it, etc. But for industry, it was simply too early. You had a system that was exotic, there was no real operating system, but even more important, there was no software, there was no support, there was no documentation, there was no network to access the system. So actually, he didn't have a chance, but he didn't know it. So he tried, and by this, it was like a starting shot. Because 10 years later, he was then gone. His successor teamed up with the Daimler boss, and they decided to found a supercomputer joint venture. So JU kind of thing as well, here with industry and the state. They also took Porsche on board. At that time, Porsche was much, much smaller. Daimler was much, much bigger. In the meantime, for some, let's say, business reasons, it's not Daimler anymore, but T-Systems. That's part of it. But this still exists today. But it's focusing on large companies. And in 2011, they said, well, we also need to do something really for the small companies. And that's where SICOS BW was founded, with focus on SMEs, and to get them going on systems. And as you all know, things have changed. Now we have Intel, AMD, and NVIDIA CPUs, GPUs that you can have everywhere. You have the same CPU more or less in your laptop. There's Linux on these systems running. There is commercial software available that scales really well. So now it's much, much better, which means that there are still some obstacles, but at least the technical things are much easier to handle. So what do we do now? Our task is to make it easier for SMEs to really access these systems. And it's not only about HPC simulation, but it's also about data analytics and AI. At the time when we started, 2011, it was large-scale data facilities, and nobody was interested because it was before big data, before AI really became widely adapted. Now this is more or less at the same level. But we not only want to have them access the system, we want them to use them. And in order to do that, they need competence partners. And of course, we are competent and our shareholders are competent, more about that later. But it's so wide an area, we cooperate with everyone who has know-how on that. So we are very, very open. And for example, if we establish a contact to a commercial software company and the SME is happy, that's a success for me. It's not about getting these people to compute on the HRS system. It's about them using the technology and benefit from it. And there's also the other way, the centers, and you'll know that soon, it's HRS in Stuttgart and SCC in Karlsruhe. They actually also, in a way, benefit from knowing what industry needs. They are both in, let's say, technical universities, so there are already industry relations, but to really have industrial users on their systems, productive use, opens another perspective that helps them understand, improve their administration and operation. And in fact, this also benefits the academic users as well. So, who are we? We have two shareholders, the Karlsruhe Institute of Technology University and the University of Stuttgart. And of course, the ministry is behind that. All the three of them fund us. In fact, we are working with the computing centers there. Those are the ones who have the know-how. Focus is Karlsruhe is more data-oriented and Stuttgart is more HPC-oriented, but both do both, and it's just a kind of prioritization a little bit. We are focusing on SMEs, which does not mean that we do not talk to Bosch or Daimler or whoever, because SMEs are typically in the supply chain and they are not isolated. So if they come up with new ideas, their customer also must be happy with it. And usually it's the other way around. The customers, the large companies would like their suppliers to work more with HPC. And we created a small ecosystem around it of solution centers, because it's not enough to just have access to the system, but we try to team up people, companies from different areas so that they form a kind of ecosystem where all the knowledge that might be necessary is combined. I'll also talk about that later. So the first thing that we really do is we offer computing as a service. So this is a great example. This is a university spin-off. So onboarding was easy because the guys developed a code at the university on the Cray computer system, and then they founded a spin-off, so they know how to do it. But it's a small company and they couldn't afford their own computer of that size, but they do simulations of industrial furnaces and boilers, lots with coal industry, which is not so popular in Europe anymore, but they have still customers from China. Where they help them to improve the furnaces in order to have less pollution. But they also look into other boilers, and this usually needs, let's say, significant resources at least for an SME. So they come to us whenever they have a customer. They use resources, a few thousand cores, much more than they could afford themselves. They, for example, also use the VR environment to show the results to their customers, and they are actually working worldwide. So for them it's easy, they know how to do it. They have to pay for their compute time because this is not research, this is really commercial use. But they are happy with it, and they are doing it, I think, since more than 15 years, sorry. You've seen Porsche on the HWW slide, that's the joint venture. So Porsche at that time, they once had for a year or two their own Cray, and they were thinking where to put it. And they didn't have compute room, so they put it in the computer room of the university. And after the 2 years, when they wanted to have the next system, they decided, why do we buy the system? There is already a system there. We could use it. And there were some intense discussions about security and operating mechanisms. But they were successful. And since, you could say, the mid-90s, Porsche doesn't have their own HPC system. They use regularly the HPC system of the Stuttgart University, and they do the real hard stuff with it. So for example, this is an aerodynamic simulation. If you develop a new car, the aerodynamics, the shape of the car is visible 3 years before it comes to market. People would very much like to see it earlier, but for the manufacturer, this is really critical. So security really is at a level where they say, okay, it's safe for us to bring our new models 3 years before they get to the market onto the HPC system. So that's doable. It's not easy, but it's doable. And they do all kinds of simulation. Down here you have, this is about water, how water distributes, how it gets stirred, how it wets your part, and they compare it with experiments, so they do really the full flavor, whatever they need. Another nice success story is Optima Pharma. They are a mid-sized company, and they produce clean room equipment and set it up. And typically it was they develop such a thing, and then they come to the customer, install it, and then it takes about 6 weeks to fix all the problems they haven't seen before. And they got a student, actually, again, knowledge transfer from education to a company. And he said, well, I know that simulation would really help. And then they looked at commercial code. Was okay, but it was too expensive for them. So they decided, let's go open source. And the student, which at that time was already, he had his master, worked with the HLS people to make OpenFOAM viable for their problem. And it took about 2 years, but after those 2 years, they installed a system at a customer and they switched it on and it worked as designed. The customer who had planned for 6 weeks of waiting time, and you know if you have a production site which goes on in production 6 weeks earlier, that's a huge amount of money. So they were really, really happy, and that set up the standard. And that's kind of revolutionizing. It's a big word, but this changed significantly what they were doing. So the next level is not only compute time, but also looking at the algorithms. This is from a project we have with KIT and other partners. I'll go to that later. Again, this is about AI algorithms. So this is the idea to improve ripeness prediction of mangoes, and based on satellite data and other parameters. And together with our partners, they have developed a new algorithm. That was a funded project. So that's, although it now goes into the commercial branch, but that helps them to reduce, well, the waste of food. And they have really put this into their business offering. If we're talking about AI, this is at least partially also based on what we did in this project. Another larger customer, ZF, a larger automotive supplier, they worked with the research partners on a conversational assistant for digital twins to make it easier for the employees to use this technology. And this was a 6-month project in order, well, the mission was to optimize the industrial process, at the same time saving energy. So that is one level higher than just using compute time. And they really, if you look on their website, the time saving is an issue, and also they see it as a boost that increases the productivity of their developers. And then I'll have a brief look on the solution centers that I mentioned before. In 2008, 2007, actually, it was founded in 2008. Somebody from Porsche talked to the head of the computing center and said, we should do something together. We need to exchange knowledge. And the idea was to form a network of members and cooperation partners from science and industry. And science, as the universities, of course, researchers, and industry includes not only the users, but also the providers. So like the HPC software and hardware providers. The idea is to create a non-academic environment where they can talk about new ideas. Of course, these ideas, they are competitors partially. Well, you will see it on some of the next slides. We have right now 55 members. What's quite funny, in the beginning, it was named Automotive Simulation Center Stuttgart. When BMW joined from Munich, they kind of were not happy. So today it's now the same abbreviation, but Automotive Solution Center for Simulation. So those are things you never imagined before that could be a problem, but it was solved. So right now, BMW, Audi, and Porsche are manufacturers in there. We have hardware providers, Hewlett-Packard and NEC. We have software providers, those you know, probably ANSYS, LS Steiner, ESI, and some others probably. So it's an ecosystem. We have service providers as well, those who help the companies do things. And of course the universities and non-academic research institutions. So it's really a great combination of knowledge, and they work together on problems. A very simple example that was successful, if you think of autonomous driving, in order to test all the cameras and algorithms and everything, you cannot drive on the road anymore. It just doesn't work. So this needs to be virtualized. So you have virtual roads. And the virtual roads are the same for Daimler, for Porsche, for BMW, for Audi. So they teamed up on that, and they thought about what they need. They found partners, and then they shared the funding. This was not publicly funded, but funded by them. And everybody was happy in the end. And this is the kind of thing that we want to ignite there. The topics are all around the car. They have special focus areas. I won't go into the details yet. You can also all find all this on their website. So again, this is not childhood anymore. Well, not mine, although I know Maya the bee. I guess you almost all probably know her. This led us to another solution center. When I started in 2012, well, I started in 2011. In 2012, we had a meeting with the creative industry in Stuttgart. And there was a company that said, well, we are about to apply for the rendering and the creation of Maya the Bee, the 3D movie for cinema. Would this be possible? And we thought about it. And when they actually got the contract, we really were able. They had the advantage. Their software was running on Linux. Which was not many software in this area don't, but they did. And looking on the paper, the nodes we had, the compute nodes at that time, were actually not much different from the ones they had, but of course we had much more. So scaling up was not a problem. We did that in between. They found out, okay, time's run out. We need 50% more capacity, which was at that time 2% of the system. So we gave them 3% for 2 months, which was not a problem. What they noticed was, though, although the CPUs were similarly fast, the rendering time was less than half on their system. Why was that? The I/O speed. Yeah, there's a lot of data that gets read and written, and we really didn't think about that before, but that improved their calculations. So they had a fixed price with their contractor, and suddenly they noticed, okay, we only need half of that money. So what could have done? Some of them would just have sacked the money, say, wow, yeah, have a party. What they did was very wise. They said, Maya the Bee, there's a lot of complicated scenery in there. There's you know, this outside in the morning with spider webs and dewdrops and haze and everything. So they decided to invest, so to speak, the money or the time, the compute time that they save to make nicer images, which had the effect to their customer. They were able to show images significantly nicer than they expected, which had led to follow-up projects ever since. So they have done Wiki or the Ritter Rost and whatever. I think almost every 1 to 2 years, they are back with us doing some computations significantly and making that. So this led to the foundation of a media solution center. So we teamed up with Film Academy, Media University. We have a museum for digital arts in Karlsruhe. And we got some 2 years funding to try out where to go. And since 2021, this has been funded. And you'll see there are some partners like the Film Commission. There's the Art Museum there. There is an orchestra somewhere. There's a chamber orchestra, theater art. But there's also a company that's specialized on communication. And there's also Europa Park. That's an entertainment park. They do virtual rides. They are interested in that. And so, for example, down here you see they actually equipped a real roller coaster, which was pretty old, with virtual reality equipment. So you have actually a rather lame ride by today's standards, but with the virtual reality, it's completely different. So they had a great investment, including that you can have different rides at the same time, not as a person, but a family could have different with, I don't know, Fairyland or the, I don't know, science fiction ride. So those are things we want to work with them more. Or, as I said, the orchestra, this was also about how to visualize music, for example, and do collaborative things. This all comes actually, this is really HPC. There's HPC beside that and behind that. And that's really, really exciting. We also scanned the theater in Stuttgart, the Opera House. You have a very nice one here as well. They have to, in Stuttgart, it's pretty old, so they have to renew it. So we did a 3D scanning and are discussing with them how to, well, rebuild it or make it new. Again, all the different flavors. We have further solution centers. There's one focusing on medical, which we are about to start right now. We see there's a huge potential for simulation and data analytics. In automotive industry, they do it since 30 years, but the medical engineering industry is much more conservative. It's also kind of much more difficult. So to have a simulation of a car crashing is today's standards. The materials are known, but if we look at us here, if we have to have a hip replacement once in a time, all our bones are different. And you cannot see them from the outside. So what is the right solution? So the challenges are much higher, but of course it's also very rewarding if you can, well, play in that field. So we are going to implement an especially institution. Again, the same scheme, just with medical engineers, the idea to allow them SMEs especially access to research results that they typically don't even see, expertise and use of new technology, also try before invest, test before invest, for example. And then we have a smaller, it's a state initiative where we do this on, well, we have done this for 10 years on smart data analytics, together with KIT. Again, we are also preparing now the foundation of an association. And then you've heard about this already a little bit. Andreas talked about it, and we heard it when the Centers of Excellence. There's a whole network of projects around this. And if I go back to my slides, so we have, well, I don't want to show that all. I just want to focus down here. Those are on the state level. So those are all initiatives that are funded by our state. We have the national project, the Smart Data Innovation Lab. We have EDI, there's a FAIR, I think is an EDI. I think there are also other EDIs here. We are partner in our EDI Southwest, which is actually co-funded also a little bit by our state. So we are really happy to have this state funding. Is that my deadline? No. I think I have another 5 minutes, but I'll speed up anyway. You've heard about Accelerate already? Well, that's Maya, the bee probably, but it's not coming from me. Okay. Okay, Accelerate EuroCC, really important. You see it all around. We are partner in all of those. And there's a new one, a small DigiHub. So that's what you have to have today, digital hubs. But this is really helpful. And I don't want to go into details. Anders, you have already talked about that a little bit. We have these competence centers, the landscape, which is really cooperation here is really important. And I was really happy to see the 5 of you sitting here. You have all understood that. And as the Germans, probably we sometimes come over a little bit arrogant. Okay, we are doing this since a long time, so we probably know a little bit more about it. But actually, your environment is a little bit different. And by talking to you and sharing our experience, we also learn about new things. So we are also very interested in exchange with you. We have the EDI Southwest. That's the Southwest, our state. Over here, we have 3 focus areas: health, automotive, and manufacturing. We have Accelerate, so don't read all this, but it's, you see, it's automotive, aircraft, aerospace, energy. There's a lot of development going around combustion and design, better emission and energy reduction, which then also can benefit not only the larger ones, but also the smaller companies. We have the Smart Data Innovation Lab with 4 well-known research, AI research institutions, but we also have industrial partners there who are interested in improving their offerings. And we have the Smart Data Solution Center from our state that I mentioned. We had helped over 250 companies over the years. We had more than 30 in-depth projects, have success stories. That's, by the way, really important. You convince, it's nothing better than a success story to convince an entrepreneur and a company. I had, we have these leaflets, that was before Corona, they were all printed. Right now it's all digital. I had 10 of them, and there was a board head of development flipping through them until he had the one of his competitor. And at the moment he saw that his competitor was doing something, he actually got nervous. He wanted to know everything. What are they doing? How long did it take? What money did they spend? I said, sorry, can tell you only a little bit, but so I got him hooked. So that's how it really, that's something that always works. Unfortunately, you cannot have a success story for every field, but the more you have, the better. And again, sharing with all these EuroCC projects, Fortissimo has been mentioned, also the EDIs is really something that helps us all. Yeah, and that brings me back to the title. So in our revolution started long ago, and it's kind of, yeah, revolution is too big a word. This is more for the single enterprise. There it can be revolutionary. If you have a new idea, a new business idea that sets you apart from your competition and is based on AI or simulation, that's really can be a revolution. But for us, and I think many of you are from these ecosystems and you are also trying to do similar things than we are, this is evolutionizing. This doesn't happen quickly. So it's not that you do it and next year everything will be fine. It takes time, and I was happy to see that you all have significant government backing, not only financially, but it's also important that they understand that it's important and that they understand it will not be done next year. The first 5 years of SICOS, our growth, so to speak, we are not there for growth, but our success was rather limited. That's the time it took to be networked and set up everything. And since then, it accelerates significantly. And I think that's also what you can do if we all work together. And that's it. There's a picture as well. And if you have any questions, I'm here until Saturday around noon, then I have to go back. So I'm looking forward to talk to all of you, and I'm absolutely willing to share everything I know. Thank you.
Thank you. So thank you for interesting presentation. Now we will move to success stories, learn from real-world industry use cases, and first speaker is Gundars Kulikovskis. He will present us high-performance computing and wood scanning application. He is chairman of ZippyVision Latvia, and
hello, everyone. I'm representing the company. We are a business company. We are not a research institution. We have, I will present one case where we use high-performance computing using GPUs and large GPUs in our applications. ZippyVision is producing the wood scanners, different technologies for automating the wood industry, for automation of the decisions made by machines. So we actually build the robots which are not moving, which are moving the things. There are 3 different videos which represents our products. And as a wood is a natural product, then there is a lot of calculations. Actually, the more the products from the nature, due to their unpredictability, are more difficult to handle, more difficult to make decisions than the human-made products, which you make and you have reference numbers you actually measure. Here, every new product is new. So we do several different things in wood industry. Mainly, these are scanners where we get the visual information, processes through the AI, and then make a decision how best to handle this product to get the highest yield. So, what is the problem we need to solve? So one of the problems are so-called rip cut optimization, which means that you have imagine that you cut a log into the boards with all the bark around it, and then you scan it, and your end product, for example, is a furniture. So every piece of furniture, depending on price, can have some knots, some coloring on it, some different things. So what you do, you solve combinatorics problem, how to cut the board in the longitudinal direction to get the maximum value from it. This problem is this problem, as you might know, is a high time complexity problem, and there is no ultimate solution. So everyone is going to the best suboptimal solution, what is in a low time is possible. Also, we should keep in mind that these machines are in the real world. So when the piece is leaving the scanner, there are limited time when we should have a decision how to cut it. And this limited time together with everything is creates the problem. So this problem in numbers here is one of the solutions found by the computer, and then in numbers we split the board in millimeter by millimeters, in square millimeters. Every square millimeter has its own quality, and we have several products on it. So actually, data points to consider is 72 million. We use heuristic algorithms and CPU-based system using 12 threads and optimized down to the processor architecture. So we had to optimize CPU first. Our algorithm was on CPU. We had to optimize even considering how it used L1, L2, L3 cache, because it was so time sensitive that we need to do different tweaks. But anyway, we process time was 6 seconds. And the machine was built, the 6 seconds buffer which was allowed for us, but it was first version and it was on CPU, and then we got a new task. We had to optimize the same thing. We had to optimize the cant. Cant is a piece in the middle of the scanner which has 4 sides, and we had to consider which side to cut, considering how to put on it the product. So the same combinatorics 2D dimensional problem, only every side of the cant can be cut in the 10 different thickness, and every thickness has its own set of the potential products, means that we had to improve our algorithm 40 times. We had to process at least 1.4 billion data points. Combinatorics, again, the same thing. The ultimate solution is never found, so we are going to do as the best we can. And what we did, so this is where we used the GPUs. We moved to GPUs, and actually this is an industrial case where by using the NVIDIA, actually we use 4090 series GPUs. NVIDIA, we are using the 5000 kernels on it, and we got 3 seconds per cycle, meaning we we twice increased the speed, and by increasing we increased actual algorithm performance by 80 times, which is for industry very significant, because that means that we can solve one of the industry problems when by selecting one of the 4 sides. This system actually is upstream to the system you saw before. First, we cut best opportunity from the cant, and then the board is going into the next scanner, which is actually cutting into the longitudinal direction, considering also the bottom part, which is not visible at the cant. And the result too, so as we moved to GPUs, we improved also the rip cut solution for boards. And the new rip cut optimization, what we did, we increased the opportunities for a customer to describe quality standards. And the more opportunities optimization has to select the products, the better is coverage with the products of the board. Means less waste, bigger yield, and actually what is important, moving to GPU increased the yield by 8%, which turns out for one sawmill in approximately 800K per year. So it's actually in the wood industry, every fraction of percent, every millimeter you save on the board cubic meters and thousands of cubic meters at the end of the year. So when moving to GPU, actually it is not an easy task. So when you work with the CPUs, you think as a small gardeners, and you expect that you will get 15,000 of them. Actually, you got one guy with a big rake, not 50,000. So it means that the programmers and software engineers have to break their mind around. They actually, to clean the park, you have to replant the trees instead of moving this big rake through it. And we expect that the GPUs and supercomputing is moving this frontier. We see the industry problem in this way, that there are two axes and everything is possible is below this line. And this high performance computing is actually moving up this frontier. The industry, there is a laser?
It doesn't work on the screen, it's not light enough.
Okay.
But you can go there.
Yeah, that's this is here. So the labs are working here usually. The industry are working here. But anyway, when this frontier is moving up, we are moving up with what is possible for industry. That is all. Thank you.
Thank you. Our next speaker is Rolandas Vaikenas. He will present optimizing meteorological insights, the power HPC benchmarking. He's head of technology solutions department at Novian Technologies from Lithuania.
Hello everyone, thank you, Mindaugas. And yeah, I'm from Lithuania, from company Novian Technologies. So what we do, we have one of the business departments we are doing. We are designing, implementing, and making support and maintenance of HPC solutions. So this is the map where our HPCs have been deployed or at least benchmarked. So yeah, Lithuania, our main country, and some more interesting and more exotic regions. So my presentation is about meteorology, about that specific domain, and I will reveal some of interesting secrets about that. So talking about how HPCs are being designed, so for a long time, the majority of the tenders in meteorological sector was like clients, agencies just provided the nodes, the CPU, the GPU maybe, memory, interconnects, and the bidders were free just to bid and according to that technical specification. What we do have now, now the majority of the projects are issued by just describing the data center parameters like floor space, like racks capacity, the electricity, the power and cooling type. Yeah, because for nowadays for CPU, for example, AMD with has almost 400 watts per one processor. So it's almost all of these processors are water cooled, liquid cooled. Of course, yeah, what's not changed is storage. So in the bidding documents, the customers are asking for storage, so it's not changed. But what is changing, that organizations are providing just data center equipment where your solution must fit, and they provide and they share the meteorological models, the specific meteorological models, and organizations are free to choose everything, just to fit into the given parameters. So talking about the success story, I'll spend some time about one project, the World Bank project. It has been finished actually a couple of months ago. It's in Bangladesh, in Dhaka. So the HPC requirements was, I mean, that's not the whole set of documents of requirements, but that's how this specification looked like. So they're providing NVP, they provided 3 meteorological models, and no gigahertz, no CPUs, no memory, no nothing, just as I said, only storage. So what we did, we had these 3 models. WRF, HIVAT, and ACERC, specific meteorological models. They are mainly related to waves and ocean waves and to floods, because this region is suffering from the floods. Bangladesh, a small country, 160 million people living in the area, which is like 2 times of Latvia or Lithuania. So what we did, we benchmarked these 3 models, and where we did that on Vilnius University supercomputer, the same one which Povilas Regis from Faculty of Mathematics and Informatics presented. So they're providing services not only for internal needs, but also for business. So we were, from that perspective, we were the customer of this client of this HPC. So at the time, we benchmarked. We came to these specific clock times. And what is interesting, why sometimes I hear questions why MET agencies are not buying resources from cloud solution providers. The answer is very simple, because the goal of their HPCs is to be utilized 100% 24/7. I mean, not to just like it to heat the air, but to provide real results. And they are running various models with specific parameters, and the need is just to fit into a 24-hour cycle. So what are the benchmarking possibilities for such a projects? So the companies are free to choose technologies, to choose CPUs, GPUs, any other technology. For instance, this is an example of, we tested for the same model, for the same specific, everything is the same, only the processors are different. So it is Intel's 56-core CPU and AMD's 36-core CPU, and we're seeing that AMD is providing better results. I mean, less is better here. And the price difference is, for example, AMD is 3 times less expensive than Intel. So it allows, if this HPC will be utilized for specific models and I mean not a universal solution, then it really makes sense to benchmark these systems. We as integrator, we have a possibility to benchmark on more than 30 or even 40 HPCs in Europe, in US. It's mainly vendors HPC solutions, but for example, the new architecture, the new processor is issued out. It's a matter of weeks or months to get it in vendor ecosystem, and then we can get access to it. Yeah, different file systems and storages. Also, you can have access to Lustre, to BGFS, or any other interconnects, 200G, 400G, 100G. I mean, everything is possible. And when this HPC is utilized, for example, for weather forecasting, for NVP models, it also makes sense to test it and on different compilers and to optimize the overall model. And as we saw in our experience, it really makes sense. You can increase the efficiency by 30 or even 40%. And you can, it's like a more theoretical one, but you can, for example, benchmark Dell over Supermicro or et cetera, et cetera. And that was one of the projects. Actually, other projects are quite similar from that perspective. Some from more interesting geography. So this year we are finishing one project in SADC countries. It's all the southern region in Southern Africa. So one quite big HPC which covers 16 countries. So 16 countries are free to use these resources for their prediction, and DC models WRF and RxMs are being deployed by our team in Vilnius, Lithuania. Other project, also similar one, Western Africa, 6 countries, project financed by the German government, and also like a shared platform for 9 countries for meteorological calculations. And that's like a technical stuff. The Vilnius University case, which Povilas presented before the coffee break, it's the same project. And yes, what about us? Yeah, what we are company about? Yeah, we're like 80 or 90 person company, IT company based in Vilnius, Lithuania. As I said, we have a team working on HPCs. We are also one of the founders of Quantum Lithuania, so we also trying to be a part of quantum ecosystem in Lithuania. And then the other projects in more than 50 countries, not also HPC, but other IT projects as well. So that's it. Thank you. And maybe if you have any questions, I'm ready to answer. Thank you.
Yes, if there is a short question, thank you for presentation. Next, our speaker is Juhani Huttunen. He will present supercomputing boosting business in Finland. He is a customer solution manager at CAC, IC Center for Science, Industrial Engagement Business Unit.
Thank you very much. So hello, I'm going to talk supercomputing boosting business in Finland. So I'm coming from CSC, which is this kind of supporting organization and for industries, SMEs, and so on, in addition to academics, which we are also providing our Lumi supercomputer and other HPC services. So I'm showing you shortly which are the usage paths that companies can, as they can become as a users in Finland, and then a few success stories, and then how we plan to go with companies in the future. So with this EuroCC, great investment for Lumi supercomputer among others. So that has bring new opportunities for everybody in Europe. Industries, 20% of the whole capacity is allocated for industrial usage. And this is really has been a deal breaker in Finland, because earlier on we haven't had really possibilities to offer our supercomputing HPC services to commercial companies, but in a very limited manner. So this Lumi capacity and Lumi HPC will bring like new era for, or has brought new era to companies in Finland. So what Lumi offers for companies, of course, world-class supercomputing capacity with cost-efficient pricing, if that's the model. Of course, faster product development with new business opportunities, including HPC data, analytics, and AI. We are able to also provide top technical expert support in HPC area in particular, and versatile training. And then it's also an opportunity that to strengthen cooperation between our academic users and these industries in this new ecosystem. And of course, with this Lumi device, it's in Kajaani in Finland, so everything is safely stored there and in a secure environment that satisfies hopefully companies' needs. So these are the 4 basic models that we are using in Finland. For companies, pay-per-use, so company makes a contract with us and pays the market price according to our price list, which is the Lumi costs and cautious margin, because we are a non-profit organization. So it's a cautious margin on top of that to ensure our operations. And this is quite unique, actually, among any other Lumi consortium countries, and also EuroHPC JU, so that we are able to offer this kind of option to companies, and it has been very welcomed with many of those. And then public funding in Finland, Business Finland is very important part of the game. So they provide computing grants, especially for startup and small medium enterprise companies, up to 100 euros, against which they can get then these HPC computing resources from Lumi, which we offer to them. And forgot to mention that these pay-per-use cases, contracted cases, we have currently maybe only 5 currently running, but there are something like 10 more cooking at the moment, coming reality in the future. This computing grant-based project, we are running 10 at the moment with commercial companies. EuroHPC JU course is, of course, always a valid option and available also for industry, but we have been able to offer, and companies have been very maybe not so much aware of this opportunity, so something to improve there in the future. And then, of course, public-private partnership, collaborating with higher education institutions, universities, or state research organizations. That's one way to go, and if the results are open, then it's free of charge, and if not, then you pay this market price as said earlier. And what we have in particular to help onboarding these Finnish companies to use HPC solutions is to offer this kind of free of charge test period. We call it Lumi Try and Buy. So they can test that everything works there, and we can also give them, in addition to these computational resources, a limited amount for limited time, also some expertise help to really get them onboarded and ensure that everything is working. So if everything is fine and they are happy, we make a contract, they continue. But if not, then they can say no, and it didn't cost anything for them, at least from our point of view. Here are 12 Finnish companies that have publicly acknowledged using Lumi. So 1 year ago we have only one here. It didn't mean that we didn't have more companies, but who have acknowledged that they are using our system. Now it's 12 and increasing. So these are varying from startup SMEs up to big companies. It's more on the startup SME side. And also many of these are deploying AI in various forms. But also these traditional HPC simulations for various application areas. And all those 4 models which I showed in the previous slides, they are in use with all these. This Business Finland grant is quite heavily used with this startup and SME companies. Now a few success stories. Rumble Finland for fire safety simulations. This is actually our very first commercial Lumi case, pay-per-use case. So Rumble is this kind of engineering consultancy company, and they are doing also these fire safety simulations. The rules are quite strict here, how you construct which kind of materials, and they are using some safety factors and so on. But more complex the building is, and if you want to optimize something, you typically go to performance-based simulations instead of this using some tables and putting some safety factors there. And more complex simulations you have, time becomes a critical issue. So Rumble were running their longest runs simulations in a week, or in any case several days. And then they come to us and said, can we help? And then we provided them Lumi. We provided them Try and Buy this with expertise support, the resources, and they wanted to continue. And now they have been our happy customer for 2 years. And it was really essential that originally we were able to provide this software HPC expert support to get them on board and get convinced that their software is working there in a proper manner. So they were happy with the 20 times faster simulations in a matter of hours compared to days earlier, and they felt that this environment was very flexible for their simulation software usage there. Another success story use case is startup company Gundars, which is a global online identity proofing company. So they are doing this kind of biometric identification, so facial recognition using AI methods there. So how it works in practice is that you want to identify a person. They have a mobile app, for example. They take a photo of their passport picture. They also take scan the chip in their passport. They take a selfie of themselves, and then magic happens. The software there, AI powered, will compare whether this picture in passport and their own picture they just took, if they are counterpart with each others. And they got this Business Finland grant in a fast manner, so they didn't have to spend their valuable time to this kind of collecting funding to do the development. They got these HPC resources, and they managed to get a much better product, more accurate, and getting the results, the identification more faster. And this was really like speeding them up to get the market. They had domestic universities as a customers, but now they are targeting for international usage of their solution. So really speeding up their work and business there. Quansient, a bit different type of company, startup that as well. So they are doing multi-physics simulations based on cloud and quantum computing. So both of those, and they have used this kind of combination and also quantum computing. They believe that that will be very valuable in fusion energy, doing digital twin of nuclear power plants, for example. In aerospace industries, maybe this kind of electric car battery design. And the problem with this quantum computing is that quantum computing is still very noisy, so there are a lot of errors. And if they want to expand their this solution, if it's more complex and bigger, in practice more realistic, you have to do something else to simulate or emulate what the quantum computing and algorithms would be doing. And in the future, of course, when they get better, they can use the actual stuff. But here they were using LUMI supercomputing to emulate what is going on and developing their algorithms, finding the bottlenecks and barriers there for the future purposes. And now they are continuing with us. They also got this Business Finland grant to start with, and we'll see which kind of model they are using in the future here. The last example I have here is about this public-private collaboration. So University of Eastern Finland, the resident Professor Antti Poso there, have worked together with Orion, and we provided this computing HPC power there. They are doing this kind of pharmaceuticals, strange name, virtual screening test or computational screening tests. And what does this mean in practice? Simply put, is that they have this kind of a drug type of molecules, and they want to dock those with this target protein to which it gets influenced. But those the database of these drug-like molecules, they are like billions and billions. And even if you would like to use high-performance computing to do all this docking and see what happens there, it would take months and months. So they got an idea that what about try to use machine learning techniques here and teach this model to take this kind of a part of these drug molecules and teach the model with those. Was it 0.1% of the whole population of these billions and billions? And when the model is trained, they do some ranking, and then they choose the best ones what the AI model proposes, and that was very successful, and they were able to increase the speed to get the results 11 times. So very successful indeed. And here, okay, maybe for the backlog of the slide sets, which are the Antti Poso's 5 theses, why this kind of a university and company collaboration is fruitful in this kind of a EuroHPC HPC collaboration environment. And as a last point, I thought that I showed something like this last autumn when we have Euro Competence Centre, this kind of a HPC summit, which have been the key success factors in Finland to support business users. So we have a variety of usage models, both Business Finland grants, especially mentioned pay-per-use as drivers. We have this try and buy test period, so lower the barrier, and enormous amount of computing resources relative to our population in Finland, you know. Then, okay, we try to focus on industry-specific domains because then it becomes more realistic to those companies and they get excited, interested. Next, we'd like to scale the expert support for them as the funding allows. And there are some enhancements in the computing environments. They need to handle more business-sensitive data there or be convinced to do so. And increase this kind of public-private project because public funders want to see this kind of a societal impact and they believe that through this kind of model, it's happening in the best possible manner. And yes, this EuroHPC funding calls that portion of LUMI capacity should be something that we should deploy much better than we are doing nowadays in Finland. That's all. Thank you.
Maybe questions? Yeah.
Thank you for interesting presentation. I would like to ask what share of services you devote to Otaniemi and Oulu regions. Can you say just in very brief?
Are you talking about academic or together? Okay, because the fact is, of course, that what we provide as our services, HPT, supercomputing, academics is clearly dominating factor there, and of course the big universities like in Helsinki University of Technology, also Oulu, there's also Tampere. Those are the biggest one, and they are the biggest users. The capital area universities, including Aalto, are those who are using a lot. About the companies then, that's maybe a more difficult question. So we allocate as much as possible we can for the companies, but many of those are coming from this like a southern part of Finland, but not limited to that. Uusimaa, yes. But that's a more difficult question. I don't have statistics to give here right now.
Okay, thank you. More questions? We have, yeah.
Thank you so much for the presentation. I have one question. Is like all the services available only for Finnish companies, or it's also available, for example, for Latvians as well?
That's an excellent question. Of course, we focus on Finnish companies or Finnish-based companies, and that's for a good reason, because all these models, especially this pay-per-use, Business Finland grant, which is Finnish agency, those we can offer within Finland. We are offering that from the Finnish LUMI pool of resources. Now, of course, if somebody is collaborating with a Finnish company or Finnish university or research institute, then it's possible, hosted by that Finnish-based something organization, it's possible to invite also others from maybe Latvia or so. It depends on the case. So in this way, it would be possible. And okay, I can't reveal any cases, but we are also nowadays considering, because there is an increase in demand with those who are happy with our solutions, that they have some sister companies outside Finland they'd like to use as well this model. Okay, easy way to say go to EuroHPC, JU calls, but that doesn't fit the picture always. So we have discussed with our ministries that is it for at least limited part of the Finnish resources to also give or sell directly to foreign so-called foreign companies. But yes, we are focusing currently in Finnish-based companies. But if you want to collaborate, that's the way to go, maybe.
Okay, thank you. Let's go back.
Thank you, Mindaugas, for the session.